Alright guys, so this is video assessment number 3C. The problem states you throw a ball at 20 meters per second at a 40-degree angle from the horizontal, starting at 2 meters above the ground. The ball lands on a flat 5-meter high roof. How long is the ball in the air and how far in the x direction does it travel? So this is a projectile motion problem, and the way we can solve this is by utilizing kinematic equations and taking the x and y components. And I'll demonstrate that right now. So, best way to start these type of problems is by writing out what you already know, what's given to us. So, we know our initial velocity is going to be 20 meters per second. We know our angle, theta, is going to be 40 degrees. And we know our y displacement is going to be 5 meters. And we don't know our x displacement. That's what we're going to try and find out. We don't know our time. And we do know acceleration. It's going to be negative 9.8 meters per second squared. And so this is pretty much all we have right now. But if we take the x and y components of our values, we can actually find pretty much everything. And the way we do that is by finding t, time, which is constant through both x and y components. And so we can start that by utilizing our y components. So we want to take the initial velocity of y, the y component. And so the way we get that is just 20 times sine 40 degrees, which is going to come out to about 13 meters per second. And using this, we can actually find out time by taking a kinematic equation. We're going to be using delta y, displacement of y, times the initial velocity, so it's going to be our y component, times time, plus 1/2 of our acceleration, times time squared. So when we fill that out, I'm actually going to write 3 here, and I'll tell you why. So the equation states that we're already 2 meters above the ground when the ball is launched. So we take the 5 meters, which is how tall the roof is, and we just subtract it. We just subtract 2 from it. So we'll get the total displacement is going to be around 3 meters. Then we take our initial velocity times time plus, or sorry, minus, because our acceleration is negative. It's going to be 4.9 squared. So what I did here was just simplify our acceleration from 9.8 to 4.9, since we do have that 1/2. And when we move this all to one side, we get that 4.9 t squared minus 13t plus 3 is equal to 0. And this is a perfect setup to use the quadratic equation. Reminder that quadratic equation is b plus or minus b squared minus 4 times ac over 2a. So when we fill that out, we get that, what is it, 13 plus or minus, sorry, this is supposed to be a negative right here. So we get 13 plus or minus square root of negative 13 squared minus 4 times 4.9 times 3 over 2 times 4.9. And with that, comes out to 13 plus or minus 11 over 9.8. And that simply just becomes 2 answers. We get 2.4 and 0.20. And the reason why we get 2 answers is because as we're throwing the ball, we already reached the height of the roof twice. We hit it once as the ball is moving up, And so that's going to be around 0.2 seconds from when we throw it from our hand. And then as it's coming down and it hits the roof, it's going to be 2.4 seconds. So that's why we get 2 answers. So now that we know time, we can fill this out. Time is now 2.4. It's pretty easy to just find the x direction, or how far the ball traveled in the x direction. We can simply use just the same kinematic equation, but using the x components instead. So we'll have delta x is going to be equal to, let's see, so initial velocity in the x direction is going to be 20 cosine 40. That's going to come out to around, I believe it's 15. Yeah, 15, around 15. We're going to have, oh, sorry. It's 15 after we times it by 2.4. Add that right there. And then plus, minus 4.9 times 2.4 squared. Simplify this, just 15 plus 28. And so we get that total distance traveled in the x direction is going to be 43 meters. And so once again, this was just a problem, that kind of projectile motion problem that demonstrates what we learned about how to split the x and y components and how we can use each other to figure out the others. So hope this helps.